adding and subtracting radicals. It is so much fun. What's like a radical? Okay, just kidding. That is not what I meant. Like radicals are radicals that have the same radicand and the same index. So here is just a reminder of the anatomy of my radical. 3 is going to be my index, and this 2 is my radicand. So in order for me to add and subtract radicals, they need to be like radicals, same index, same radicand. Whoops, that should have showed up. There we go. Okay, adding, subtracting radicals. So here I have 2 times the square root of 8 plus 3 times the square root of 2. Do they have the same index? Yes, they are both the square root, but do they have the same radicand? No, they do not. Okay, I have the radicand of 8 and a radicand of 2. That looks like it's not going to work, but let's see if we can simplify and make it work. Okay, so first step, simplify each radical. When I simplify 2 times the square root of 8, I know that the square root of 8 is just 2 times 2 times 2. And I can leave 3 times the square root of 2 alone because that's pretty simplified. Okay, do you see doubles? I see doubles. That means I can pull it out. Okay, so really this is just 2 times 2 times the square root of 2 plus 3 times the square root of 2. So 2 times 2, we know that is just 4, so let's simplify that. 4 times the square root of 2 plus 3 times the square root of 2. My second step is to combine like radicals by adding or subtracting their rational factors. So we had 4 times the square root of 2 plus 3 times the square root of 2. We know that they're square root of 2, right? There's basically, this is the square root of 2 plus the square root of 2 4 times, and the next term is the square root of 2 plus the square root of 2 plus the square root of 2. So how many square root of 2's do we have? And I probably should have written this off to the side, but I did not. You have to use your imagination or use the paper and pencil that you should have with you while watching these videos. I can also just factor out that square root of 2. So I have 4 plus 3 times the square root of 2. 4 plus 3 is just 7. So this is 7 times the square root of 2. Let's look at some practice. Okay. So number 1 is pretty easy. We need to check if they have the same index and the same radical. Do they have the same index? Yes, they do have the same index. It is just the square root. Do they have the same radicand? Absolutely they do. It is just 3. So that means we can just look at the 4 and look at the 2 and add them up and keep the radical. So 4 plus 2 is 6 times the square root of 3. Easy peasy. So, whoopsies. So number 2 is looking at the square root of 45 plus the square root of 18 minus the square root of 5. So we can see that they have the same index, but they do not have the same radicand. So let's try to simplify it and see if we can find some like radicals. So 45 is just 5 times 9, and 18 is 9 times 2. So I just went ahead and I wrote that out because I can use the product property of radicals and pull out these 9s. Okay, they don't have to be in there anymore. The square root of 9 is 3. So I'm going to pull that out, and I'm going to do that again here. So it should be 3 times the square root of 5 plus 3 times the square root of 2 minus the square root of 5. So I'm looking again for like radicals. I can see that this is in the square root of 5 family. I have 3 over here, and then I'm subtracting 1 over here. So again, if I were to visualize this, that 3 times the square root of 5, that means it is the square root of 5 plus the square root of 5 plus the square root of 5. And now you're going to subtract 1. Okay, so that is going to leave you with 2 the square root of 5, and then plus 3 times the square root of 2. There are no other radicals that are like that square root of 2, so he gets to hang out by himself, but it's all good. Let's practice one more time. So the reason why I have this complicated one is because if you can do this, then you're good. You're good to go on your homework. Okay, I wanted to do a harder one with you guys. So I'm looking at ways that I can simplify my radicals first. And the first thing that I see is this x squared. Well, that makes things super easy for me because I know the square root of x squared is just x. So there's one way I can simplify. The other thing that I see here is 75. 75 is just 3 times 25, and 25 is a perfect square. So that looks good to me. And then I have 18, which is like our similar problem. 18 is 9 times 2. So 9 is a perfect square, and that makes me happy. So I'm going to rewrite this now. I pulled out my x from that first term. So it's x times the square root of 2 plus 3 times 25 times, oh, there we go, x squared, okay, minus 2x squared times rad 3 minus x, and then all of that. Okay, so I'm going to show you how things simplified. I had my x squared, I pulled him out. 75 turned into 3 times 25. X to the 4th power turned into x squared. So we know from the power to the power rule, whatever that was called, that you multiply your exponents. So 2 times 2 is 4. Our third term stayed the same, and our fourth term, 18, turned into 2 times 9. So let's pull out our perfect squares. So I see 25 and x squared, and then I also have 9. So I'm going to pull it out and simplify. So if you notice here, I not only simplified, I color coded. And this is something that I would do on paper if I had colors. If not, I would use highlighters, and y'all know me on my board. I would use squares, boxes, underline, just so I know where my like terms were, in this case like radicals. You can use the same thing, same process, okay? So I put my radical 2's in orange and my rad 3's in pink. So I'm going to combine my like radicals. For the square root of 2, I had x minus 3x. I'm going to write that off to the side, and that's times the square root of 2. And then on my other side, I'm going to write 5x squared times the square root of 3, very quickly apparently, and I'm going to simplify. So what is x minus 3x? And remember, you do need to keep your x's. You're just looking at the coefficients of that. So it's really 1 minus 2 times x. I'm sorry, 1 minus 3. Just kidding. Okay, so 1 minus 3 is going to be negative 2x times the square root of 2. And on the right, we have 5x squared times the square root of 3 minus 2x squared times the square root of 3. So if you had 5x squareds and you're only removing 2 of them, you're going to be left with 3x squared. So let's go ahead and rewrite that. So there I have it. And I'm going to take a look real fast and make sure I can't simplify anymore. In my radicand, I'm left with prime numbers, so I can't simplify that. And then outside of my radicals, it looks pretty simplified. Everything is together. So that is it for today. Thank you so much for watching the video, and I hope you have a wonderful week.